In this problem, we need to divide using long division when I have the polynomial x cubed plus 5x squared minus 11, and it is divided by the binomial x plus 3. Whether we're using long division or synthetic division, it's very important to look for missing terms in both of our polynomials. In the numerator, I have an x cubed term, x squared, and a constant. There's no x term there. And it's very important I put a placeholder for the x term in order to keep everybody lined up. So my numerator is going to be written as x cubed plus 5x squared plus 0x. There's my placeholder for the x term, minus 11, all divided by, there are no missing terms in the denominator, it's just an x term and a constant. So you're dividing by x plus 3. The process of long division of polynomials is very similar to the process of long division of numerical expressions, and I want to review that quickly since it's most probably quite a long time since you've done it. If I wanted to do 98 divided by 8 by long division, I have my division bracket, 98 goes inside and 8 goes outside. Then you divide 8 goes into 9 one time, 1 becomes part of the quotient. Then you multiply 1 times 8 is 8, and then you subtract. 9 minus 8 is 1. And then you bring down the next number, which in this case is an 8. 8 divides into 18 2 times. 2 times 8 is 16. Subtract. 18 minus 16 is 2. So this is 12 with a remainder of 2. And that's the process I'm going to do with my polynomials. So I write my division bracket, and my numerator or dividend goes underneath, so that's why I'm putting x cubed plus 5x squared plus 0x minus 11. And my denominator, my divisor, goes outside. So we're going to take the leading term of the dividend, x cubed, and we're going to divide it by the leading term of the divisor, which is x. So x cubed divided by x is x squared. That is part of your quotient. So write it up here, lining up like terms. And now you're going to multiply x squared times x plus 3. And if you need to do it, you can write it out here on the side. You don't have to. So x squared times x is x cubed. Then x squared times 3 is plus 3x squared. And now we need to subtract these two polynomials. And it's much easier to change the sign of the second one and then add. You make a lot less mistakes that way. So positive x cubed becomes negative x cubed, and plus 3x squared becomes minus 3x squared. So now we're ready to add. X cubed added to a negative x cubed, those add up to 0. And if they don't, you've done something wrong, because this process is designed to eliminate that first term. Then 5x squared plus a negative 3x squared is 2x squared. And now bring down the next term, so I'm going to bring down a 0x. That's the end of the first round. Now we need to repeat the process. Leading term, 2x squared, divided by this leading term, which is x. So 2x squared divided by x is 2x. So I'm going to do plus 2x up in the quotient. And then I'm going to multiply 2x by my divisor of x plus 3. And I get 2x times x is 2x squared. 2x times 3 is plus 6x. Now change the signs and add. So this becomes negative and negative. 2x squared minus 2x squared adds up to 0. They cancel each other out as designed. 0x added to a negative 6x is negative 6x. Bring down the next term, bring down the negative 11. Repeat the process. Negative 6x divided by x is negative 6, part of my quotient, and then multiply negative 6 times my divisor of x plus 3. Negative 6 times x is negative 6x. Negative 6 times 3 is negative 18. So now I need to change my signs and add. So this negative 6x becomes plus 6x. This negative 18 becomes plus 18. And so I'm going to get negative 6x added to 6x. Those add up to 0. And then negative 11 plus 18 adds up to 7. So in this problem, 7 is the remainder, and my quotient is x squared plus 2x minus 6. But normally we write the answer as the quotient x squared plus 2x minus 6, then plus the remainder of 7 over the divisor of x plus 3. So that is the way we normally write our answer.